Bienvenidos al ciclo de conferencias Universidades por la Ciencia, organizado por Fundación UNAM, el Colegio Nacional y un grupo de universidades y centros de investigación en México, Estados Unidos, Inglaterra, Brasil, Argentina, Chile. Les agradecemos mucho el interés y que nos acompañen. Y el día de hoy tenemos una conferencia muy especial a cargo del doctor Alan Robock, quien es profesor distinguido en la Universidad de Rutgers en New Jersey, en Estados Unidos. El doctor Robock es un especialista en ciencias atmosféricas y tiene dentro de sus investigaciones los efectos de erupciones volcánicas, la parte de geoingeniería en el clima y el invierno nuclear. Welcome to the Universities for Science Seminar Series organized by the UNAM Foundation and a group of universities and research centers in Mexico, the US, UK, Brazil, Argentina, Chile. Thanks very much for your interest. And today we have a very special conference by Dr. Alan Robock, who is a distinguished professor at the Rutgers University in New Jersey. Professor Robock is a specialist in atmospheric sciences, in meteorology, and has a very broad interest, including the effects of volcanic eruptions on the climate change, the geoengineering, the climate system, and the effects of a nuclear detonation, nuclear war on the climate, including the nuclear winter. Professor Robock is a very good friend. He has been in Mexico many times, and we are delighted to have him today. Thanks, Professor Robock, for accepting the invitation. And well, we look forward for a coming meeting in Mexico sometime this year. And Professor Robock is a fellow of the American Geophysical Union and has received multiple recognitions for his investigation, for his research work. The seminar cycle is characterized by a presentation of research in progress, and is retransmitted by the UNAM research centers in the US, the UK, Spain, and many other places. And we welcome your questions, and we thank all of the students and the professors and colleagues who are joining us. The presentation will be in English, and we invite you to make questions and comments in Spanish and English. So we will go back and forth. In the panel, we have the president of the UNAM Foundation, Professor Dionisio Meade, and the executive director of the UNAM Foundation, Araceli Rodríguez. Bueno, muchas gracias nuevamente. En el panel tenemos al presidente de la Fundación UNAM, Dionisio Meade, y la directora ejecutiva de Fundación UNAM, Araceli Rodríguez. Y el ciclo de conferencias que ha resultado muy exitoso se caracteriza por presentar investigaciones que están en desarrollo. Y esto pues ha permitido reforzar la colaboración internacional, que es la base de la actividad en ciencias y en innovación. Entonces, les invitamos a que nos hagan preguntas, comentarios a través de las redes de Fundación, y trataremos de tomarlas al final de la conferencia. Thanks very much. And I will now invite our president, Dionisio Meade, to make the welcoming remarks. Thanks, Alan, and great seeing you.
Thank you very much, Jaime, and thank you very much, Alan. Muchas gracias por estar con nosotros y muchas gracias a todos quienes nos acompañan en este ciclo de conferencias que hoy se reanuda con este tema que tiene que ver con lo que pudiera pasar con el hambre global después de una guerra nuclear. Es un tema muy difícil, muy preocupante y que cobra actualidad, pues porque las sombras de la guerra y las nubes de la guerra están oscilando en distintas partes del mundo y se ve ahora con particular preocupación algo que ojalá siga siendo preocupación de los teóricos, pero que empieza a tener un espacio de materialidad que a todos nos preocupa en el mundo. Y queremos celebrar que se reanuden nuestras pláticas en este consorcio. Como lo hemos platicado en ocasiones anteriores, el consorcio fue una respuesta a las adversidades de la pandemia. Y justamente frente a esas adversidades, con el apoyo de Jaime Urrutia, que es miembro de la Junta de Gobierno de la UNAM, es consejero de la Fundación y es miembro del Colegio Nacional, se diseñó la realización de este consorcio, la creación de este consorcio, en el que lo que se ha venido haciendo es sumar la voz de especialistas de distintas universidades del mundo que nos han venido compartiendo su conocimiento, su experiencia, su avance y su investigación científica para que todos en el consorcio puedan beneficiarse de este conocimiento y que de este intercambio surja también la posibilidad de enriquecer lo que cada uno en su ámbito de competencias está haciendo. Pero nos motiva de manera particular que de estas presentaciones se pueda suscitar entre los jóvenes que nos escuchan esa inquietud para que su quehacer profesional se pueda alimentar de este conocimiento. Nosotros hemos dicho en la Fundación que los estudios, que la posibilidad, la oportunidad de hacer estudios superiores cambia historias de vida y cada una de las presentaciones que aquí se hacen nos acredita por voz de quienes participan que la realización de esta investigación y de estos estudios no solamente han cambiado sus destinos, sino logran también cambiar las decisiones de políticas públicas, pero motivan también a muchos jóvenes a realizar también sus estudios alrededor de los temas que son objeto de estas presentaciones. Como nos han dicho Jaime Urrutia, el doctor Robock, que es especialista en muchos campos de la ciencia, pero tiene una especialidad y una preocupación particular de lo que podría derivar para el mundo en términos de hambruna y en términos de cambio climático si se suscitara este riesgo que quisiéramos que nunca se pudiera materializar, el de una guerra nuclear. Por eso escuchamos con particular interés la presentación que hoy nos hará. Agradecemos que nos acompañe, agradecemos a Jaime la invitación que le ha hecho para que podamos continuar con este ciclo de conferencias y agradecemos a todos quienes participan. Y quizá lo más motivante para Alan Robock sea que al final de la presentación muchos jóvenes estudiantes, muchos jóvenes que estén realizando sus primeros pasos en su especialización profesional puedan no solo realizarle preguntas al doctor Robock, sino puedan después verse tan motivados que quieran hacer de estos estudios profesionales la motivación y el contenido de su próxima futura vida profesional. Muchas gracias a todos, bienvenidos y nos da mucho gusto reanudar este ciclo de presentaciones de nuestro consorcio por las universidades, agradeciendo de manera especial a la Universidad Nacional Autónoma de México, a quien nos debemos en Fundación UNAM, al Colegio Nacional y a todos quienes integran este consorcio por su participación activa en la presentación de estas conferencias. Gracias a todos, bienvenido doctor Robock, bienvenidos todos y procedemos a escuchar con mucho interés la presentación que se nos tiene lista para hoy. Gracias, Jaime.
Gracias. Thanks, and Alan, please.
Thank you very much for inviting me, Jaime, and your colleagues. I'm really glad that you're interested in this topic. And today I'm going to talk about global famine after nuclear war. This is the obituary of Sherry Rowland in the AGU journal EOS. And he got the Nobel Prize in Chemistry with Mario Molina and Paul Crutzen for his work on atmospheric chemistry and the destruction of the ozone layer. He said, what's the use of having developed a science well enough to make predictions if in the end, all we're willing to do is stand around and wait for them to come true? Is it enough for a scientist simply to publish a paper? Isn't it a responsibility of scientists, if you believe that you have found something that can affect the environment, isn't it your responsibility to actually do something about it, enough so that action actually takes place? And so it's these ideas that helped stimulate me to do this work. It's kind of depressing, but I want to prevent it from happening, and that's what inspires me to tell people about what I've found. So my talk will be about the theory of nuclear winter, analogs. We can't actually do the experiment in the real world, so how can we test it? Then the policy implications, and then doing something about it. This is a picture at the AGU meeting 3 years ago when we had a poster session of the old guys working on this. Rich Turco, Brian Toon, Tom Ackerman, me, and Georgy Stenchikov. And we'd been working on this for 40 years. But there are also some people, and right now I'm working with Brian Toon very strongly for the last 5 years trying to advance this work. But we also have some younger people. Cheryl Harrison and Nikki Lewandowski are oceanographers. Lily Shaw and Jonas Jagermeyer are crop modelers. Julie Lundquist models fires in cities and how much smoke can go up in the atmosphere. And Mike Mills, Chuck Bardeen, and Josh Koop are doing global climate modeling. I also have a group at Rutgers where we're looking at impacts of climate change, not just from soot in the atmosphere after nuclear war, but also from geoengineering, the idea that you would emulate a volcanic eruption and put sulfur up there. And we're mainly working on improving crop models so that we can look at the impacts of stratospheric aerosols when you get cooling, when you have additional ultraviolet radiation and ozone impacts. And so my work is funded by National Science Foundation of the US, the Open Philanthropy Project, and Silver Lining. We published many papers on this. You can go to my website, which I'll show you again at the end, and download copies of any of them that you want. These are from the last few years. We've published in Science and Proceedings of the National Academy of Sciences, many AGU journals, GRL, JGR, Nature journals. But the public still doesn't seem to know much about it. So we're trying to make people more aware of this. Here's the story. Here's our beautiful Earth with Mexico here. And after a nuclear war, however, it might look like this, with a cloud of smoke covering the Earth, blocking out the sun, and making it cold and dark at the Earth's surface. If there's enough smoke, temperatures will go below freezing even in the summertime, and we call that nuclear winter. You would get cold, dry, dark, more ultraviolet radiation because the heating of the stratosphere would destroy ozone, let more UV through, and this would have a huge impact on crops. And so we've now been able to really quantify this for each country, which is what I'll show you today. Let's start with what causes nuclear war. It's the use of nuclear weapons. And this is a graph of the deployed nuclear weapons in the world. And you can see that the US was the first one, and then Russia, Soviet Union, and then there was a nuclear arms race, and we got up to over 60,000 nuclear weapons in the 1980s. But then the arms race ended, and the number's been going down ever since. There are 7 more countries with nuclear weapons, but each one of them has a very small number, and so this total includes them, but there'd just be flat lines across the bottom here. Why did the arms race end? Well, I think scientists had a role in it. In 1982, Paul Crutzen, who shared the Nobel Prize with Sherry Rowland, and John Birx pointed out after nuclear war, they were looking at ozone impacts, but they also pointed out there would be smoke from fires, which would change the amount of sunlight, which would change the photochemistry in the troposphere. And oh, by the way, they said that smoke could cause climate change. Nobody had thought about that before. So then Alexandrov and Stenchikov in Russia, and Turco, Toon, Ackerman, Pollack, and Sagan, which we call TAPS in the US, published a paper. And then the next year, Covey, Schneider, and Thompson, and I published more papers in Nature, all pointing out there would be nuclear winter. And then the arms race ended. Well, you might say maybe there's other reasons. Well, the Soviet Union did not end until 5 years later, long after the arms race was over. And I also like to point out that although the numbers have been going down, there's still 10,000 nuclear weapons deployed, so it's still not zero. So how do I prove to you that we had a role? We scientists, to do our work, look at data, look at observations, we use models, calculations, we use theory, but historians don't do it that way. They just ask the people that made the decisions. And so the two people that made the decisions were Ronald Reagan in the United States and Mikhail Gorbachev in the Soviet Union. And Reagan said in an interview, a great many reputable scientists are telling us that such a war could end up in no victory for anyone because we'd wipe out the earth as we know it. If you think back to natural calamities in the last century, volcanoes, we saw the weather so change, there was snow in July in many temperate countries. And they call it the year in which there was no summer. Now, if one volcano can do that, what are we talking about with the whole nuclear exchange, nuclear winter? And Gorbachev said, models made by Russian and American scientists showed that a nuclear war would result in a nuclear winter that would be extremely destructive to all life on Earth. The knowledge of that was a great stimulus to us. So Soviet scientists and American scientists got the same result, and they trusted it. And that really helped. There were also a lot of anti-war demonstrations. People were anti-nuclear demonstrations. People were worried about nuclear war, and that had an effect too. But that was 40 years ago, before most of you students were born, I imagine. Why are I even talking about it now? I want to answer two questions. Although the Cold War and the arms race are over, could the remaining nuclear arsenal still produce nuclear winter? As I mentioned, there's 7 new countries with nuclear weapons now. What would happen if they had a nuclear war using a much smaller number of weapons? Say, what if India and Pakistan had a nuclear war? What would that do? So I'm going to answer these questions now and show you how I got the answers. Yes, we can still produce a nuclear winter, and it would last for a decade, much longer than we thought before. A smaller one would not produce nuclear winter. That is, the temperatures wouldn't get below freezing, but there would still, the direct effects would be horrific, and there would still be impacts on global agriculture and food for a decade. I'll show you that. So during World War II, the beginning of 1945, the US decided that it was too dangerous to try and bomb Japanese cities during the daytime because their bomb sites weren't very good and they could get shot down. So they developed a policy of burning down cities at night. On March 10th, they painted an X with napalm on Tokyo at night, and then more than 300 planes came in with incendiary bombs, and the city burned down, and more people were burned to death in 24 hours than ever before or since in history. This is a map done by the US Army at the end of the war, and they showed all the cities they bombed, and they put the equivalent size of the cities. So Tokyo was the equivalent size of New York, Yokohama, this equivalent size of Cleveland. And this was a policy. Every 3 days or so, they did it, sending fleets of airplanes with these incendiary bombs. But then they developed atomic bombs. And the last 2 cities that burned down were Hiroshima and Nagasaki. In each case, it was only 1 bomb each. So the policy was already well established. They killed 800,000 innocent women, men, women, and children. Hiroshima was the size of Seattle in Washington state. So on August 6th, a 15 kiloton bomb killed about 150,000 people. A kiloton is the explosive power of 1,000 tons of TNT. It's 1,000 times stronger than any bomb ever used that was not an atomic bomb. By today's standards, though, it's pretty small. And so the total arsenal today is so big that if you dropped a Hiroshima-sized bomb every 2 hours, every day, starting on August 6th up to today, more than 76 years later, we still couldn't use up the current arsenal. This is the airplane that did it, the Enola Gay, named after the mother of the pilot. There's me back when I had, this was at the Air and Space Museum in Washington, D.C. Now it's been put on display. And this is me when I had some hair and it was black. And this is a mock-up of the uranium bomb that they dropped on Hiroshima called Little Boy. The picture on the left is the mushroom cloud produced by dropping the bomb on Hiroshima. The picture on the right was taken 3 hours after that, and you meteorologists will recognize this looks like a thunderstorm. Indeed it is. It's a pyrocumulonimbus caused by the fire, which then pumped the air up, and water came in and condensed, and it produced a huge thunderstorm, which pumped the smoke up into the stratosphere. Other studies have shown that because there's so much smoke, the water droplets are very small, they don't grow, and so there's very little washout. And there was more energy in the fire that burned down Hiroshima than there was in the bomb that dropped it. This is a picture made by one of the survivors of Hiroshima. What they remember is the fires. And here's another one. And this is what Hiroshima looked like afterwards. All the buildings were burned and ended up in smoke. There were a few stone or buildings still left. 3 days later, we dropped a plutonium bomb, which was spherical, on Nagasaki. It was called Fat Man. This is a picture I took a couple years ago in the Peace Museum in Nagasaki. This is a picture of Fat Man and the bomb. And this is the mushroom cloud. It was a 20 kiloton bomb. And this is what Nagasaki looked like afterwards. Now, speaking of analogs, well, you don't need an atomic bomb to burn a city. This is San Francisco in California. There was a big earthquake in 1906, and it produced a fire that burned down San Francisco. Jack London, the famous author, was asked to write about it for a big weekly magazine. He said, within an hour after the earthquake shock, the smoke of San Francisco's burning was a lurid tower visible 100 miles away, 160 kilometers. For 3 days and nights, this lurid tower swayed in the sky, reddening the sun, darkening the day, and filling the land with smoke. I watched the vast conflagration from out on the bay. It was dead calm, not a flicker of wind stirred. Yet from every side, wind was pouring in upon the doomed city. East, west, north, and south, strong winds were blowing upon the doomed city. The heated air rising made an enormous suck. Thus did the fire of itself build its own colossal chimney through the atmosphere. So this indeed was a pyrocumulonimbus, just like happened over Hiroshima. And this is what San Francisco looked like afterwards. A few stone buildings were remaining. So this is today's nuclear arsenal. 13,000 nuclear weapons. This is done by the University of Nagasaki. They do it every year. So this was a little less than a year ago. The graph has a red missile it represents 5 missiles, land-based. A blue is 5 sea-based missiles on submarines. A green is 5 bombs on airplanes. And the gray are retired or to be dismantled. This is the Russian arsenal, the US arsenal. They have several that are not deployed. The 10,000 I showed you before was just the ones that are deployed. These are the other 7 countries. It's a little hard to see, so let me blow it up for you. The US and Russia each have 6,000 weapons. The other countries have many fewer, a few hundred. Pakistan, India, 160, Israel, 90, North Korea, 40. So if you believe that you want to use nuclear weapons, why do you have them? For deterrence, to stop another country from attacking you. How many do you have to put on their capital city to deter them from attacking you? And when I ask that question, everybody says 1. Okay, so maybe you need 2 in case the first one doesn't work. So a couple hundred is more than enough. These countries could build as many as they wanted. They stopped here. This makes me ask the question, why do the US and Russia still have thousands and thousands? Why don't they bring their arsenals down to the size of these countries? Then that we couldn't have a nuclear winter. It also makes me ask the question, what about there's 190 countries in the world, only 9 with nuclear weapons. Why did the other 180 decide not to have any nuclear weapons at all? What can we learn from them? This is a picture taken from the International Space Station. And this orange line is the border between 2 countries. I ask audiences, what 2 countries are these? Sometimes they say North and South Korea, but that's not correct because there would not be lights on both sides of the border. These lights are big cities. And actually this is India, Pakistan, Afghanistan in the distance. And these lights are huge cities, some you probably never heard of. So Karachi, Faisalabad, Lahore, millions of people. And if there was, and Pakistan, India both have nuclear weapons. So if they had a nuclear war, these cities would be targeted and burned. So the place we thought nuclear war was most likely when we did this work a few years ago was in Kashmir, because this area is disputed by Pakistan and India. And there are always incursions. Sometimes there are even wars, small wars fought. About a month ago, India, by mistake, launched a cruise missile into Pakistan. Fortunately, it didn't have a nuclear weapon on it. It didn't do any damage, but even more fortunately, it did not start a nuclear war. So, but things could get out of hand. What if there was a skirmish and due to poor communication, misunderstanding, panic, and fear, it started a nuclear war? So we asked this question 15 years ago. We tried to study this. What would happen at 100 nuclear weapons? So we assumed they would have Hiroshima-sized weapons because those are the easiest to build. So what if they each used half their arsenal on targets in each country that would produce the maximum amount of smoke? And the direct effects would be horrific. Maybe 20 million people could die, almost half the total number of people that died in all of World War II. Portions of cities would be exposed to fallout. There'd be maybe 6.5 million tons of smoke from the fires going up into the stratosphere. So I decided to be conservative. We looked at what would happen if there were 5 million tons of smoke injected into the upper atmosphere. This scenario doesn't have, this is just one story of how a nuclear war might be fought. It doesn't have to be India and Pakistan. It could be India and China. It could be some other countries. So this is just, we did it for an example, but we don't mean to say that this is how a nuclear war would be fought. We used a state-of-the-art climate model at the time from NASA, the GISS Model E, 4x5 degrees horizontal resolution, which is pretty low resolution by today's standards, but it had a stratosphere and a mesosphere. And we could put the smoke in the upper troposphere and it would be heated by the sun, lofted into the stratosphere. And it's the first time we were able to do this calculation, and we did it for 10 years. And this is a movie I made. On the right is where the smoke would go horizontally. And on the left is where it would go vertically, averaged around the globe. We live down here on the troposphere. This is a border. This is called the tropopause. This is the stratosphere. And the smoke would be heated by the sun and lofted high up in the stratosphere, be blown around the whole world and last for years. The E-folding lifetime would be about 7 years. And so this would last much longer than we ever thought before. I plotted the global average temperature change on the graph of global average temperature that we know and love, global warming. We trying to bend this curve, and I spend a lot of time working on global warming, but I just wanted to point out that the climate change with 5 teragrams, 5 million tons of smoke would cause instant climate change, not gradual climate change. And it would cool the earth so much, it wouldn't be nuclear winter, but be temperatures unprecedented in recorded human history. Temperatures below the Little Ice Age. Now, no climate model is perfect, and so 2 other climate modeling groups did the same calculation with a model from Switzerland, a model from the National Center for Atmospheric Research, and they got the same result. Global cooling for more than a decade, unprecedented in recorded human history, using the power of much less than 1% of the global nuclear arsenal. But it's much worse than that. This is a Trident nuclear submarine. It can have 100 nuclear weapons, and they're 100 or 500 kilotons, not 15 kilotons. So one of these is 1,000 Hiroshimas, not 100 Hiroshimas like I just showed you. The US has 14, that's less than half of our arsenal. So maybe we have 25,000 Hiroshimas. Russia's got the same thing, 50,000 Hiroshimas, not 100. So now that we had a modern climate model, we said, let's go back and see if nuclear winter really was correct, because the climate models available at the time, you could only run a general circulation model for 20 days, and the one column model used by TAPS left out much of the physics. And so we went back and we put in 150 teragrams of smoke, and we also put in 50 teragrams because we thought maybe a third of the amount of smoke. And what could produce 150 teragrams? Well, that's the same nuclear winter scenario used 40 years ago, because they only used a third of the arsenal, and it ended up for every target in the US and Russia, there were still 9 weapons for every target. So even today, 4,000 weapons could produce this much smoke. Here's a movie of what would happen, much thicker smoke. Again, it would last for many years. And so we went to the first year, year 1, after the war started in year 0. This is the temperature change at the surface. Huge changes in Northern Hemisphere summer, JJA, huge changes at the surface, especially over land. And let's take a point. This is, we published this 15 years ago. It just happened to be in Ukraine, which is where there's a huge amount of agriculture, although unfortunately it looks like not this year. And this is a plot of the surface temperature, minimum daily temperature at that point in Ukraine. The black line is our control case. So in the summer, it would get up to it would warm up 20, 25 degrees. In the winter, it would get below freezing. But if you put the smoke in May, it would quickly go below freezing and stay below freezing for a couple years. So this would really be nuclear winter. And you obviously could not have agriculture at all for a couple years. We recently repeated this calculation with the Wacom model at NCAR, a much better model in terms of higher resolution, more processes. And we were surprised that the results are basically exactly the same. The top is temperature change over 15 years. The bottom is precipitation change. And the physics are very simple. If you block out the sun, no light gets through, it gets cold at the surface. Then we went back to think about Pakistan and India. In a few years, they're having their small mini arms race. They each have 160 now. And we figured, what would happen if they fought a war in a couple of years? So they have more weapons. Their weapons are stronger now. Some of them are boosted, and the targets are larger. And so we asked, what would happen if India used 100 weapons and Pakistan 150? It could produce 50 to 125 million people would die immediately. And the fires could produce not 5, but 16 to 36 teragrams of smoke. We published this in Science Advances. And here's a graph of the surface temperature. So the green is the US-Russia case that produces nuclear winter. The blue is the 5 teragram case, about a 1 degree cooling. And these others are these different amounts for India, Pakistan, the amounts of smoke. So depending on the scenario, you could get 5 degrees cooling for 50 teragrams. And so this is a graph of global warming, 5 teragrams of smoke, 50, 150. This is from the GISS model. And I just remind you, I had to rescale this, of course, to fit these on here. When there were ice ages 20,000 years ago with kilometer-thick ice sheets covering North America, the global average temperature was about 5 degrees Celsius colder than normal. So this would be ice age temperatures for several years. It wouldn't produce an ice age because after the smoke fell out after a decade or two, there would be enough sunlight, the snow could not stay and produce ice. So the most important impact of climate change is our food. So we looked at how it would affect agriculture. Of course, it would be dark, there'd be less sunlight, it would be colder, so there would be slower growth. Maybe there would be killing frosts, there'd be less rainfall, and there'd be toxic chemicals, genetic stocks you couldn't use their current seeds, There might be lack of fuel for machinery, water, pesticides, enhanced ultraviolet. So we're trying to look into all of these, but so far what we've done is looked at the basic things that affect agriculture: temperature, rainfall, and light. And we're working on UV. So we've written a paper which is under review right now at Nature Food. We've gotten the revision back. We're writing the second revision, making some small changes that will be published soon. Lily Shaw is the first author. She's done most of the work. And so let me just show you what we've got so far. We calculated crop response using the community land model, which is part of the community or system model at NCAR. And we simulated the major grain crops, maize, rice, soybeans, wheat, and we simulated grasses because that's what animals, grazing animals, eat. And then we also ran a fishery model, because if you can't grow crops on land, can you go fishing? And for cattle and sheep, on average, half are fed by pasture and half are fed by crops. So we also looked at what would happen if we didn't feed these animals, but ate the food ourselves directly. And we used Food and Agriculture Organization, FAO, data for the calorie content of each food, national import and exports of food, and national consumption of all the different foods. So we looked country by country, how would they be affected by these different scenarios? First, I'll show you how the temperature changed, how the calories changed. So this is the total caloric change from crops for the different scenarios. And so for the globally average, for the nuclear winter, it would be 90% reduction in the amount of food. For the others, maybe 30 to 40%. For fish, the reductions would be smaller because the ocean temperature wouldn't change as much. But fish is less than 10% of the total global diet. So crops and fish together, it looks very much like this figure here. And for grass, which some animals graze on, it'll be a little bit larger reduction than for this. So how do we put it together? Well, the average diet per person is 2,900 kilocalories per person per day. In the US, we call these calories, maybe you do in Mexico too. The main crops, grain crops, 50%, other plants, 30%, livestock. Now, livestock includes meat, fish, dairy, and eggs. Fish are right here, 18%. And how are crops used? Well, these dark wedges are the fraction of each crop that humans eat. For maize, corn, maize, only 18% is eaten by humans. Most of it's used for feeding animals. Some of it's used for biofuels. For rice, most of it's eaten by humans, and the same for wheat. For soybeans, most of it's fed to animals. So we took all this into consideration and looked at how the food would change. And we had various assumptions. In one assumption, we kept the livestock and kept feeding it. So there would be reduction in cereals, reduction in vegetables, fruits, and nuts, reduction in marine catch. The marine fishery effort would stay the same, but for these cases, we kept portions of the livestock, or we just said no livestock. We're going to consume what we have, and we're going to feed the food to humans. And we would boost the production of fisheries. For a couple years, you could enhance the fisheries, but then there'd be no fish left. And so, and for livestock feed, we would use it for animals and for humans. Humans can't eat all the stuff that's fed to animals, so portion for human consumption. And so so we assumed in the first year, all the food that's stored would be used up. There's about a 2-month supply of food. So for the first year, all the food would be used up, and people could only eat what was grown. And I said the average diet was like 2,900 calories. If it's 1,900 or less, then you'll be losing weight. You won't live very long. If it's red, less than 1,145 calories, people would die pretty quickly. And for the partial livestock case, 50% of the feed was used for humans, the 50% used to feed livestock. And this is for each country. At the end of year 2, what would happen? And on the average, people would be starving to death in the higher latitudes. for these intermediate India-Pakistan cases, and certainly for the US-Russia case. So how many people would die then? So for the livestock, partial livestock, no livestock case, this is the number of millions of people that would die in each country. So the big countries, of course, many people would die. For the smaller countries with not that many people, fewer people would die. But we said, well, what would happen if then we said, okay, some people are going to die, so let's not feed them anything. A very draconian case, that how it would really work out would be much more complicated. Let's assume people are going to die anyway, don't get any food. We save all the food for the people that are going to be alive at the end of year 2. How many people would die in the world? And so for the 37 teragram case, India, Pakistan, for the 150 teragram case, we used 2010 data. That was the most recent data we had, where the world population was 6.7 billion. For the livestock case, 2 billion people would die. For the India-Pakistan case, for the US-Russia case, 5.5 billion people would die. And it doesn't matter what you do with the livestock, because if you feed them and eat them, or you eat part of their food, it doesn't make any difference. Now, I mentioned UV. So in the 5 teragram case, the stratosphere would get very hot. This is a time series, years, altitude, because the smoke would be heated by the sun and it would destroy ozone. What would happen if there was severe ozone loss and enhanced UV? So for humans, you would get sunburn, increased skin cancer, cataracts in your eyes. For crops, it would affect how they grow. It would affect the soil bacteria, genetic damage, and more susceptible to attacks by insects. For the fish, the phytoplankton, the basis of the oceanic food chain, would be decreased. We haven't been able to incorporate this into our calculations yet, because we're building a better model that includes UV. So the results above did not include the UV effects. But we recently calculated how the UV would change. On the left is the India-Pakistan case. Because the smoke wouldn't be that thick, the excess UV could get through it. And so the blue line is excess UV change. The red line is the UVC, which would cause DNA damage. And so there would be excess UV. For the US-Russia case, because the smoke would be so thick, even though there'd be more UV coming through the stratosphere, it would be absorbed by the smoke and wouldn't get to the ground until the smoke cleared. Of course, most people would be dead, so it wouldn't make much difference. What about analogs? How can we test this theory? Everything I've told you has been based on calculations. Well, in the winter it gets cold, less sunlight. At night it gets cold. So we have a gut feeling for how temperatures would change. We saw that cities can burn. What about smoke and dust transport? I could spend a whole hour talking about this. I'm just going to give 2 examples: volcanic eruptions and forest fires. The asteroid impact killed the dinosaurs. So there was a big forest fire in Canada a couple of years ago in 2017, and it produced a pyrocumulonimbus, which pumped smoke up into the stratosphere. And then the smoke plume was heated by the sun and lofted another 10 kilometers and blown around the world. And we modeled this with the same climate model we used to model nuclear winter, and we were able to do it successfully. And because of that, we got a paper in Science. And so there's one graph. It showed the rapid ascent of the smoke. The solid lines are observations from satellites. The dashed lines are models. And so rapid ascent in the first 10 days, both modeled and observed. 2 years ago, there was an even bigger fire in Australia over the December and January that pumped 3 times as much smoke up in the lower stratosphere. And that smoke was observed to go 20 kilometers up in the stratosphere and last for more than a year. And so these natural experiments done by forest fires help validate that part of our theory, where our theory, you put much more smoke in the stratosphere. This is the Tambora volcano that Ronald Reagan mentioned would produce the year without a summer. Here's Haraldur Sigurdsson standing up on the crater. And so it produced a year without a summer. Here's a graph of the temperatures in New Haven, Connecticut in the years after the Tambora eruption. This is degrees Fahrenheit. This is 68 here is 20 Celsius, and 59 is 15 Celsius. So several degrees Celsius cooling. And it produced food problems in North America, in Europe, in India, in China, and Asia. And Gillen Wood wrote a book about this, said, for 3 years following Tambora's explosion, to be alive almost anywhere in the world meant to be hungry. So the science conclusions are a nuclear war between any nuclear states using less than 3% of the current world arsenal could produce climate change unprecedented in human history. Such a small nuclear war could produce global starvation with massive increases in ultraviolet radiation. The current arsenal can still produce nuclear winter, killing most of humanity. So how do you feel? It's pretty depressing, you know? And what do you do? How do you deal with this information I just told you? The most natural reaction is to forget about it. Pretend I didn't tell you. As Mark Twain said, denial ain't just a river in Egypt. It feels better just to not process something so horrible. But my reaction is to do something about it. I want to prevent something like this happening. I'm not the first one who's had this impulse. So there have been treaties to limit the testing of nuclear weapons, the Partial Test Ban Treaty, the Comprehensive Test Ban Treaty. And so the US and Russia have not tested nuclear weapons either underground or in the atmosphere for more than 30 years. A couple countries, India and Pakistan, North Korea, have done a few underground tests, but basically testing is gone away. What about limiting the number of weapons? So the Non-Proliferation Treaty gave special status to the first 5 countries, US, Russia, China, India, France, and UK. And it tries to prevent proliferation. Then there have been treaties between the US and Russia to reduce the weapons. And the only one that's still in effect is the New START Treaty, which was signed by Obama and Medvedev in 2010. And it limits each side to a maximum of 1,550 deployed nuclear weapons. But each bomber counts as one, so maybe each side has 2,000 strategic nuclear weapons. But as I just showed you, 4,000 nuclear warheads can still produce nuclear winter. In addition, there's a lot of smaller tactical nuclear weapons that can be used on the battlefield. Russia has about 1,000, the US has 100 deployed in Europe. This treaty was extended by Biden as soon as he became president, and Putin in 2010, so it's currently in existence. And there have been intrusive inspections on each side, so we know that it's being followed. But most of the world doesn't have any nuclear weapons. This graph, all the countries in blue here have no nuclear weapons. The Southern Hemisphere has no nuclear weapons. Latin America has none. In the Northern Hemisphere, there's 1 country with nuclear weapons, the US. In Europe, there's 2, France and England, and there's 6 in Asia. The countries in yellow have a treaty with nuclear weapons, and they sort of feel like they're protected by the nuclear umbrella. Even Japan, which is the country that actually had nuclear weapons, dropped on it. And the US actually has nuclear weapons based in Turkey, Italy, Germany, Netherlands, and Belgium. How did this happen? Well, there were treaties to eliminate nuclear weapons. The Antarctic Treaty, the Latin American Treaty, the Treaty of Tlatelolco, which was organized by Alfonso Garcia, the Mexican foreign minister, and got rid of all nuclear weapons in Latin America. They're also prohibited outer space, the seabed, South Pacific, Southeast Asia, Africa, Central Asia. And the last treaty is called the Treaty on the Prohibition of Nuclear Weapons. It was signed in the United Nations in 2017. It came into force last year after 50 countries had ratified it. And this is the will of all the other countries in the world, telling the nuclear nations, we don't want you any nuclear weapons because we're afraid of what will happen to us if you use them. They say, oh, well, we keep them for deterrence. We're not going to attack you, but deterrence doesn't work against pandemics, against terrorists, against cyber warfare. It does not even work against attacks on nuclear nations by conventional weapons. So the Soviet takeover of Eastern Europe, when the US was the only one with nuclear weapons, the Algerian War, the Yom Kippur War, the Falkland Islands, the Malvinas War, who won Afghanistan wars, who won the war in Vietnam? All these nuclear nations, their nuclear weapons did not help prevent invasions or even win wars. What about deterrence? Well, against nuclear nations, well, it's true. There has not been a war between two nuclear nations since World War II. Why? Was it deterrence or was it something else? A general decline in violence, increased interdependence, NATO, EU, UN. But even if you believe in deterrence, it has to be perfect. It has to last forever with no mistakes. But there have been many close calls. Well, first of all, Brian Tooner and I pointed out, actually, if you attack another country with your weapons and they don't even do anything back, you're all going to die from starvation. So really, it should be self-assured destruction, not mutual assured destruction. So that should deter people too. But the closest we came to a nuclear war was in Cuba. And this was a display of a Russian nuclear missile there were 36 of them based in Cuba. Each one had a 1 megaton warhead, 77 times more powerful than Hiroshima. There were 36 there. I took this picture in Havana. And the closest we came to a nuclear war was October 27th, 1962. A U-2 spy plane was shot down over Cuba. A Russian submarine almost launched a nuclear torpedo. But fortunately, it didn't. And I had the very surreal experience of being invited down to Cuba to give this talk about nuclear winter. And the second time I went, I sat by Fidel Castro. And the second time I went, I sat across the table from him for more than 3 hours when he told the story of how what happened in the Cuban Missile Crisis. He actually told his whole life. He said, the Russians sent us a ship every day with supplies, and when they wanted to put nuclear weapons in here, what can we say? But Cuba was one of the first countries to sign and ratify the ban treaty, the Treaty on Prohibition of Nuclear Weapons, and Mexico was too. So it's a baseball cap I brought him as a present from Rutgers. So President Kennedy and Nikita Khrushchev decided not to have a nuclear war, and they put an embargo, a barricade around, a blockade around Cuba, and Russia got rid of their nuclear weapons. But President Kennedy understood this 60 years ago. He said, every man and woman and child lives under the nuclear sword of Damocles, hanging by the slenderest of threads, capable of being cut at any moment by accident or miscalculation or by madness. The weapons of war must be abolished before they abolish us. But it didn't happen. No president has done it. So Martin Sherwin wrote a book about the Cuban Missile Crisis. So the real lesson is that nuclear armaments create the perils they are deployed to prevent, but are of little use in resolving them. And it was really good luck. So what can we do? Well, in my opinion, we can take our US land-based missiles off a hair trigger alert. We don't have to launch them immediately. The president has the sole authority to launch nuclear weapons. Why? We can make our policy no first use of nuclear weapons. All options don't have to be on the table. We can get rid of our land-based missiles, which are have to be used or lose them. And if there's a warning that there's an attack, you have to be sure the warning is correct. So in order to produce this treaty to ban nuclear weapons, there were 3 conferences on humanitarian impacts of nuclear weapons. And I went to the first and second conferences. I went to one in Nayarit in Mexico near Puerto Vallarta in 2014 and talked about our work then. And there were 146 nations, and they were pressing the nuclear nations to get rid of their weapons. And then the negotiations began in 2017, and the treaty was reached. Now comes the hard part, getting it signed. And so after 50 countries ratified it last year, it came into effect. And now there are 60 countries that have ratified it. And Nobel Peace Prizes were given to several people trying to get rid of nuclear weapons. Here's a list of them. And one of them was given to Alfonso Garcia Robles from Mexico, who played a key part in the laborious efforts to make Latin America a nuclear-free zone. He was lauded as Mr. Disarmament. And in 2017, ICANN, the International Campaign to Abolish Nuclear Weapons, got the Nobel Peace Prize for its work to draw attention to the catastrophic humanitarian impacts of any use of nuclear weapons, which is partly based on our work, and for its groundbreaking efforts to get that treaty through the United Nations. I love their symbol. And Beatrice Finn, when she accepted the Nobel Peace Prize, she said, "The story of nuclear weapons will have an ending, and it's up to us what that ending will be. Will it be the end of nuclear weapons, or will it be the end of us? One of these things will happen. The only rational course of action is to cease living under the conditions where our mutual destruction is only one impulsive tantrum away." She said this when Trump and Kim were arguing about whose button was bigger. And she's repeating what John Kennedy said 50 years earlier, almost 70 years earlier. What are the policy conclusions? Nuclear weapons can be used if they exist. A nuclear war could start tomorrow by accident, hackers, computer failure, bad sensors, or unstable leaders. Nuclear arsenals did not deter attacks from non-nuclear states, terrorists, or pandemics. The only way deterrence could work is if states believe other states are willing to kill themselves by using their nuclear weapons, and if there's a guarantee there will be no unintended use. The only way to prevent a global catastrophe is to actually get rid of nuclear weapons. Carl Sagan, the American astronomer who was one of the authors of the first paper on nuclear winter, was asked, "Don't you want to keep our weapons for a deterrence?" And he said, "For myself, I would far rather have a world in which the climatic catastrophe cannot happen independent of the vicissitudes of leaders, institutions, and machines. It seems to me elementary planetary hygiene as well as elementary patriotism." I agree. Elementary planetary hygiene demands we eliminate nuclear weapons faster than the current pace. And I hope we can learn from this and keep our beautiful planet looking like this for a long time to come. If you want to learn more about this work, you can go to my website, and I'd be happy to answer any questions.
Thanks very much, Professor Robock, for a really very interesting conference and the message. I think it's a very important message. We really want to keep the planet alive. We have many emails and comments congratulating you for a very interesting presentation, and also good days and regards from many different places here in Mexico, including Yucatan, Chihuahua, and Mexico City, and also from Uruguay, Argentina, and Chile. They send you best regards. We have several questions. Some of them are about this, about the existence of these strategic and non-strategic nuclear bombs, and the deterrence, if this is really working. From your presentation, it is clear that the effects of a nuclear war, even a small one, will be catastrophic, far beyond the direct casualties. So they argue that how can well, the United Nations and the international organizations address this deterrence is clearly not working.
Well,
How can
this treaty on prohibition of nuclear weapons, which we call the ban treaty, was passed by the United Nations. The United Nations has two bodies, has the Security Council and the General Assembly. The Security Council has 15 members, 5 of them are permanent, US, Russia, China, UK, and France. Just by chance, those 5 countries are the first 5 to have nuclear weapons. And any treaty would not get passed by the Security Council because they would veto it. These 5 members have a veto power. So ICANN was very clever. They got the treaty through the General Assembly, and it won by a landslide. And these 5 or 9 countries with nuclear weapons could not veto it. So that's how they got the treaty passed by the United Nations. It's now in effect. 60 countries have ratified it, which means nuclear weapons are illegal. But the 9 countries with nuclear weapons have not ratified it yet, have not signed it. So this is pressure from the rest of the world telling them, we don't want you to have nuclear weapons. And the number is going up. There will be a meeting of state parties of the countries that have signed it in June in Vienna. It was supposed to be in January, but it was delayed by the pandemic. So there'll be a meeting, and several of the countries which have not signed it, their activists in those countries have required that they attend and listen to this. And so there's still pressure, including in NATO countries, for countries to sign the ban treaty. If you think that violence is the way to solve problems, there are very powerful precision weapons that you don't need to use nuclear weapons. And a nuclear weapon is so powerful that it kills everything for kilometers around and destroys many innocent people. There's something called the law of war, which prohibits you from killing innocent civilians. Russia is breaking that right now by their attacks on civilians, but they're using conventional weapons. A nuclear weapon would kill many more people. The nuclear countries say, oh, our nuclear weapons are not targeted at civilians, they're targeted at military targets. But it turns out there are many military targets in cities around the world. The Pentagon, the White House, the Kremlin, and where they command and control. And so many cities would be targeted. So I don't understand how nuclear weapons could ever be used. There's no rational way to actually use them. And if you believe that violence is a way to solve problems, you can use so-called conventional weapons.
Okay. But a related question is if the other countries, nuclear countries, like France, UK, do they have small bombs or only the big ones?
Many countries
How is
have,
the distribution?
many countries have so-called tactical weapons too. So these would be on a cruise missile or a bomb that could be dropped from an airplane, or even on artillery shells. During the Cold War, there were many tactical nuclear weapons in Western Europe because the Russian army had many more people than the armies in Europe. And they said, we're going to use nuclear weapons to defend us in case the Warsaw Pact, people in Eastern Europe, attack Western Europe. But the people living there didn't think much of the idea. They said, you know, our cities in Germany are only 1 kiloton apart. You know, they thought that if they were ever used on the battlefield, it would do huge damage to the people there. For example, if Russia used an atomic weapon in Ukraine, the radioactivity, depending on the wind direction, would blow over Russia and do a lot of damage there. And so using nuclear weapons on a battlefield makes no sense because it would damage everybody, not just the target. And so it doesn't make any sense to use them on a battlefield. But as Kennedy said, as Beatrice Finn said, and as we've seen examples of people, including the former president of the United States, who really didn't trust to be rational about things like this, that if people like that can control weapons, there can be, accidents can occur either by a sensor that says that you're being attacked. That happened several times and almost started a nuclear war. The US Defense Secretary was woken up in the middle of the night when Jimmy Carter was president. We're being attacked by the Russians, and it turned out they had put a training tape into the missile defense system, and they thought that it was a real attack when it was really a training tape. The Russians saw a sounding rocket going up from Norway, and they thought the US was attacking. Norwegians had told the Russians they were going to launch a rocket, but somehow there was a miscommunication. And so there have been many close calls, and many we don't even know about. So they could be used by accident or by crazy people. That's why it's really scary. I think we've had really good luck that in 77 years, there hasn't been a second nuclear war.
It's worrying. It's a risk we have as long as we keep the nuclear bombs. There is a question about the effects are different depending on location. I think it's because of the map you show that most of the nuclear nations are in the northern hemisphere. The question is that if the southern hemisphere will be as bad affected as the northern one.
So the maps I showed, the effects on food depend on several things. They depend on where the smoke is. The smoke would cover the whole world, but at higher latitudes, there would be more cooling and less cooling in the tropics. The southern hemisphere has a lot more ocean, and so the southern hemisphere temperature change would be less. But also, I showed maps of how many people would die. So it depends where the people are too. So, for example, Australia doesn't have that many people. They grow a lot of wheat, and at a latitude not very high, so their temperature change wouldn't be as large. So they could probably feed most of their people. In Russia or China or the US or Canada, there would be huge impacts on the amount of food being grown, and there's a lot of people. So it depends on several factors. And then it depends, of course, on more details like how the food is distributed and things like that. But it would still be a catastrophe. What if you say, I'm going to go to New Zealand because there aren't many people, there'll be lots of sheep and stuff, but how are you going to get your medicines? How are you going to get the spare parts for your phones, for your computers? How are you going to, these countries all depend a lot on international trade. So even if you could grow a little food, maybe you could survive at Stone Age level, at a pre-industrial level, but modern civilization would be destroyed. So when people say, well, how can I survive? Can I build a fallout shelter and just wait it out? Well, if you have enough food for 10 years, you have a way to get water, you have a way to clean the air, you have enough weapons to keep your hungry neighbors out, maybe you could survive, but I don't call that surviving. The best way is to prevent it from happening.
Okay. A related question is how long can the cold and darkness last in the southern hemisphere?
It would be about the same. So it would be for 5 years, would be the maximum effects, and then they would gradually tail off as the smoke fell out of the atmosphere. So after 10 years, the effects would be pretty small. But we've also found that there are some feedback processes in the ocean that prolong the effects. So in the Arctic Ocean, there would be more sea ice, and even after the smoke was gone, the sea ice would last for a long time.
Recording in progress.
We have a paper that's in review right now looking at the long-term ocean effects. We also had a paper showing there would be an El Nino for like 7 or 8 years of the US-Russia nuclear winter. And so there'd be a lot of regional effects too, and effects on the ocean that would last for a long time. So it's interesting to see the atmospheric dynamics and ocean dynamic response, which most people don't care about. They care about food, but we were also writing papers on how the climate system responds too. And these are useful to inform us maybe about an asteroid impact, or a supervolcano might have similar effects.
Oh, okay, thanks. Well, there are some questions about how is the climate system affected, and the interaction, the teleconnections, and there is one about the effects on the events like El Nino, like Enzo.
So we have a paper about that. So the website I gave you, I guess the chat's not working here. Can I put something in the chat? Can everybody see the chat? The thing I just put in the chat?
No, not really. Perhaps we need help.
Well, if you can spell my name, Robock, you can go to Google, type my name in. It's an unusual name. You'll find my website, and you can look up my website on nuclear war effects, and all the papers we've written are there at this website, and you can download the PDF. And there's a paper on El Nino. Let me, can I share my screen again? So
Yes.
Here's our web. Yes.
Well, okay, sounds good.
So here's our website, and all of our publications are here. And this one by Josh Koop, Nuclear Nino Response Observed in Simulations of Nuclear War Scenarios. So you can click here and get the PDF, and you can download it, and it shows the whole papers. It's available, it's open access. So we've done that. We've also looked at the atmospheric circulation in winter warming and wintertime. You get a positive mode of the Arctic oscillation and winter warming, even though the globe is cooling. We have a paper on how much smoke gets injected into the upper atmosphere, and one on ozone loss, which I told you about, one on fisheries, one on crops for the 5 teragram case, ocean acidification. So all those are there. So you can get all those there. And if you can't, just send me an email and I'll point you to it.
Okay, thanks. We will make the link available, and
Okay.
great. We have the link to the papers. Some of the students are asking where they can find papers and additional information. So we will send this to in our platform. And there is a question of if the atmospheric circulation will be affected for a longer time. How is the climate system affected by this discrete effect on the, if something happens in the long term?
Well, you can look at the paper on winter warming and the paper on nuclear Nino, and you can see how there are changes of circulation in the tropics associated with the relative warm temperatures in the tropical Pacific, but also because you're heating the stratosphere in the tropics more than at high latitudes because there's more sunlight there. You get a stronger pole to equator temperature difference, a stronger jet stream, and a stronger Arctic circulation. It's a positive mode of the Arctic Oscillation, a stronger polar vortex. And that blows warm air from the ocean onto Europe. And so for the first winter, even though the globe is cooling, you get warmer temperatures there. We find that after big volcanic eruptions too. After a while though, that effect goes away. But so we show all of that in those papers. And if anybody wants some output of variables that we didn't plot in our papers, we can share those with you. We have the output on a disk somewhere. If you want to do further analysis of the impacts of the simulations we've done, there's a lot of questions still people could ask by looking at that.
Okay, thanks. And there are some comments, not exactly a question, about if other components of the climate system, or for instance, the ozone layer are affected. I think it's because of your comment on the work by Crutzen and by Mario Molina.
Well, the first paper on my list there was by Chuck Bardeen, and he shows that the smoke is black, so it absorbs sunlight and heats the stratosphere, and that has a huge impact on ozone chemistry, and it destroys ozone. So that paper has I showed you one figure of that about how much UV gets down, but the paper has all the details on the ozone. And so, yeah, that's all there in that paper.
Okay. And there are some comments about, in addition to the cold and the darkness period, what happens with the radioactivity?
Okay,
this is also affected by the atmospheric circulation.
So radioactivity, there would be a lot, of course, where the bombs were dropped. And then depending on the wind direction, there'd be a plume of radioactivity going downwind. This book, The Cold and the Dark, is oh no, not this one. This one. This one, Nuclear War, the Aftermath. This is a copy of the Ambio journal, which did a special study, the Swedish journal 40 years ago. And they have maps in here of the plumes of radioactivity. So this is North America. This is Europe. So the places where there are these plumes, there would be radioactivity there, and that would have a huge impact. But globally, it wouldn't be very much. It depends also on where the bombs are dropped. If they're dropped on land, say a missile silo, there'd be a lot of dust and radioactive dust. If they were blown up in the atmosphere to have larger damage, then they wouldn't produce as much radioactive dust. So we're in the process now of using our climate model to calculate for different scenarios how the radioactivity would change over time. But it would not be as much of a concern for most people, as it wouldn't be as much of a concern as would food. Food would be the major impact, not radioactivity.
Oh, thanks. And there are some questions, including one by Epifanio Cruz, about about the Ukraine and the invasion of Russia. How serious is the threat for a possibility that they use a tactical nuclear bomb?
So that's not my area of expertise. What's going on in Putin's mind, I don't know. But I try to warn the world about the use of nuclear weapons. If one is used, how can you be sure that there will not be more used? There are various war games by generals from one side, generals on the other side. They say, okay, a tactical nuclear weapon is used to stop your troops. What do you do? In some cases, the opposite says, okay, I'm in shock, I'm going to stop, I can't do it. In other cases, well, we've got to retaliate. We have to show that we're strong, so we'll use one. And then the other side uses two, and you get escalation, and you get a global nuclear war. It's not a very good data point because there's only been one nuclear war, but in that nuclear war, the entire global nuclear arsenal was used. It was two. But they were going to use another one the next week, but Truman stopped it. So, but how can you be sure that there will not be escalation? If only one bomb was used, it would be horrific where the bomb was dropped, and there would be a plume of radioactivity. Many people would die instantly. Other people would die slowly from the radioactivity. There are people who were in Hiroshima who are still alive today, who go around, hibakusha, who go around talk about what happened, because they can tell the story, because they happen to be a wall between them and where the bomb dropped, so they didn't get the radiation from the bomb, didn't hit them, and they were able to leave and not breathe or eat radioactive material, and they're still alive today. So it would be different, but the direct effects would be horrific. But it would not cause global climate change. One bomb would not cause global climate change. I did a calculation. Another paper on my website has the effects of all those bombs dropped in Japan in World War II. I did a calculation what the global temperature change would be. It might be 1 or 2 tenths of a degree Celsius, but because of the data we have, our climate record, it would be in the noise. We couldn't detect a significant change. Locally, it would be horrific, but globally, it wouldn't be something that you could detect.
Oh, thanks very much, Alan. And I hope well, the nuclear war can be avoided. I hope that the international community is aware, and that it's a very important message. Well, we have regards from many people, including Claudia Prieto Mulateri from Rivera in Uruguay. Nazira Ordorica send you personal regards and thanks. And well, we thank all of the students and professors and people who has participated, and we well, thanks very much, Alan. It's a very important message, and well, we are very glad to hear about your research for many years on this important topic.
Thanks very much for your interest in this. I'm sorry that people still have to be interested in it. I'm sorry that it's still a thing that people have to worry about, but thanks for your interest. Mexico's been a leader in anti-nuclear action for decades, and so I mean, Mexico doesn't have any nuclear weapons, and you're just fine. Why do you need them? You don't waste your money on building a nuclear arsenal. You use it for other more important things. So that's a good example for the world. Jaime, could you send me those personal emails? Just forward them to me later.
Yes, certainly. We will send you also a copy of some of the questions, and
I can answer them offline. I can answer people if you don't have time for them now. I can answer them.
Okay. Well, thanks for joining us for this interesting conference, and we congratulate Professor Alan Robock for his research, and Professor Mead will close the seminar. Nuestro presidente Dionisio Mead va a cerrar la transmisión. Muchas gracias a todos.
Muchas gracias, Jaime. Muchas gracias a la presentación que nos ha hecho favor de compartir el doctor Alan Robock. La verdad es que los cuadros, las láminas que presenta son preocupantes. Yo diría que son hasta horrorizantes, pero que podría pasar si todo esto continuara y si algún día se materializara este riesgo, que está disperso en varios centros del planeta y que, como ahí se menciona, podrían detonar este riesgo formidable que hoy se nos ha hecho favor de compartir. Un riesgo que pues ha sido combatido por mucha gente, y varios premios Nobel, como aquí se menciona, han estado asociados a este esfuerzo por la paz, y subrayamos ahí la presencia del doctor Alfonso García Robles, que fue un premio Nobel de la Paz y que para orgullo nuestro es egresado de nuestra Universidad Nacional y que encabezó, lideró este esfuerzo que puso a México en el mapa de la desnuclearización. Yo creo que la batalla tiene que ir más lejos que disuadir la contienda nuclear. Yo creo que hay que evitar ciertamente este invierno nuclear, pero hay que frenar, yo diría, con un cambio mucho más profundo, todo lo que se gasta en armamentos. Aquí se nos ha hecho énfasis en lo que se ha gastado, en los riesgos que se materializan en el espacio nuclear, pero los armamentos forman parte de un gasto enorme que realiza la comunidad mundial y que podría encontrar en un entorno distinto espacios mucho más productivos, mucho más cercanos a las necesidades de la humanidad. Tenemos que terminar con esta lógica de que el hombre sea el lobo del hombre. Tenemos que apagar ese concepto de que si vis pacem para bellum. No podemos vivir siempre con esa amenaza. Tenemos que cuidar sobre todo lo más valioso del planeta, la presencia de la humanidad, su sobrevivencia, que no solo reclama, sino que con toda razón pretende más justicia, más equidad, más inclusión, igualdad de oportunidades, compartir ilusiones, vivir con esperanza, vivir en paz. Yo creo que todos anhelamos un mundo de esta naturaleza. Y esa es la lección que me llevo de la presentación que hoy nos ha hecho favor de compartir. Esta posibilidad de que nos vayamos con un compromiso de cimentar un mundo mejor. Creo que muchos de quienes nos escuchan podrán encontrar este mensaje y podrían aportar sus conocimientos, sus investigaciones, sus vidas, la semilla que podrán llevarse para hacer de su vida profesional un mundo mejor. El esfuerzo, también aquí se ha señalado, es mucho más que frenar la amenaza nuclear. Es instaurar un mundo de paz. Es también frenar el deterioro de la amenaza climática, de ese cambio climático que ya llegó y que tenemos que enfrentar y que tenemos que combatir. No tenemos de otra. Esta es nuestra casa común y esta casa común la tenemos que cuidar. Muchas gracias al doctor Robock porque nos ha hecho favor de recordárnoslos y creo que aquí habrá muchos jóvenes que habrán de dedicar su vida profesional en sus muy distintos ámbitos a la paz, en la investigación, en el conocimiento, en la dedicación de su vida a este valor supremo de la convivencia entre el hombre. Muchas gracias a todos, gracias por su presentación y quedemos emplazados para seguir escuchando estas presentaciones que a través del Consorcio de Universidades por la Ciencia tenemos la oportunidad de compartir con nuestro auditorio. Muchas gracias de nuevo y seguimos en contacto para poder continuar escuchando estas presentaciones que habrán de seguir presentando estos temas de investigaciones en curso con los que queremos compartir esta inquietud, este valor de los estudios de educación superior, a través de los cuales hay siempre una mejor oportunidad de vida para la humanidad. Muchas gracias a todos y muy buenas tardes.